In life, you are most likely to encounter a lot of books. Some of them may be good, some of them may be not worth the time at all, but sometimes we get very valuable books, either from academic background when we were students, or if you're lucky, still gathering books for your professional career. That's why I decided to make one very brief list on the typical books that you will encounter as a student and most likely that you are going to still be searching as a professional graduate. Most likely, if you're focusing your attention into an actual technical or process engineering career. Now, the list is not going to be in any particular order, so make no worries. All these books are really great. Now, let's get started. One of the very initial topics that you will encounter is mass balances, material balances, or maybe the subject as it is, material and energy balances. This is by far one of the most important subjects, and definitely you are going to encounter one of these two books, if not both books. I'm talking about the Elementary Principles of Chemical Processes by the famous Richard Felder and the Basic Principles and Calculations for Chemical Engineering from the famous author Himmelblau. Both of these are great books. Actually, initially, when I was a student, I had both of them. I started with Felder's book and then switched it to Himmelblau. And truth be told, guys, is that when I was a student, I really loved Himmelblau's book. It was very straight to the point, but as a graduate, I really started to get in love with Felder's book. It is much more focused toward processes and actual industrial applications rather than theoretical concepts, so that's always welcome as a young engineer working in the industry. Now, for sure, both books are great picks, so don't hesitate into buying one or getting both books. If you can only get one, maybe I will go for that of Felder's book. Afterwards, it's very common to get started with thermodynamics, either a very theoretical approach, maybe equilibrium thermodynamics, physical chemistry, or go directly into the actual thermodynamic core topics, or maybe we're talking about thermodynamic in processes, whatever the case this may be. I'm going to be recommending Sengel's book on thermodynamics. It's a very broad approach towards thermodynamics, but I really think it's great for a general engineering understanding on thermodynamics. And what do I say a general understanding? It's mainly because you can find a lot of books that are focused toward chemical engineering applications, of which I will be recommending the Introduction to Chemical Engineering Thermodynamics from the great guys Smith, Van Ness, and Apple. This is definitely one of the top picks that I would recommend for any chemical engineering student. And although both books are really great, one focuses the attention more towards the thermodynamics in general engineering applications, overall ways in which thermodynamic principles can be applied to the industry. But the one of Smith, Van Ness, and Abbott is definitely one of the most that I enjoy. It's very straightforward if you're a chemical engineer. It has a lot of applications to the chemical industry, but more importantly, it focuses its attention to the mole quantity. And Sengel is most likely going to be focused towards mechanical or civil engineers, which all the time they try to avoid the molar quantities. So, truth be told, is that whenever you go into thermodynamics, you need to understand that these are atomic and molar quantities that need to be understood. Hence, my best pick will go for Introduction to Chemical Engineering Thermodynamics. Transport phenomena is for sure one of the most disliked, even hated subjects that you're going to encounter in chemical engineering. It is very unfamiliar, not likely to be suited for almost all engineering profiles, and it is really focused more towards the microscopic things that happen whenever we're talking about heat transfer, momentum transfer, and even mass transfer. Now, for sure, this is the fundamentals of the understanding of all the unit operations that are eventually going to go through this. I'm talking about pumping systems, compressors, fluidized beds, heating systems, heat exchangers, condensers, boilers, and of course, all the separation processes. Distillation, lixiviation, flash operations, membrane operation, and many other types of units. Now, the mighty Bible, the mighty book that will be recommended is that of Transport Phenomena book by Bert Stuart Lightfoot. BSL. Yeah, BSL. And you are going to be recommended by any chemical engineer that this is the top book. But in my opinion, it is not a nice or welcoming book. It is very straight to the point. The understanding, the notations, the terminology, and all the things that make this book are not that welcoming for a freshly graduate, but also, guys, for an engineer overall. whenever you present this book to chemical engineers, process engineers, mechanical engineers, it is not the best impression that you're going to get. It is, of course, hard to understand, very technical, very scientific, but definitely one of the best books for transport phenomena. On the other hand, guys, when I graduated, I got to know this book, Transport Processes and Separation Process Technologies by Jan Koplis, or Jan Koplis, or Jan Koplin. Sorry for butchering the name, guys. I'm not really into pronunciation. But nonetheless, this is one of the best books that I will strongly recommend you guys. Of course, we have Transport Phenomena by BSL, which is the main pillar and fundamental Bible for every transport phenomena student. But if you really want to understand this in a much more applicable way, much more welcoming, and of course, way better structure, I would strongly recommend you the one on Jan Koplis. And of course, being a chemical engineer, it's all about designing, operating, and working with unit operations, which are essentially the equipment used throughout the industry. Now, truth be told is that typically you will be choosing a book that focuses into heat transfer, mass transfer, or momentum transport, fluid mechanics, maybe reactor engineering. But I have one of my best picks, and I'm talking about The Unit Operations of Chemical Engineering by McCabe, Smith, and Harry. This is the GOAT and go-to whenever you want to learn more about general specifications, general applications, and of course, their design fundamentals. Stated before, this is very generic content, but will for sure give you the fundamentals on what are unit operations and why we need them, how to design them, and how to work with them. Now, stated guys, whenever working with unit operations, it is much more likely that you're going to be picking a book on the specific niche application. Let it be heat transfer, let it be combustion, let it be reactor engineering, let it be distillation processes or so. And this is what we're going to be doing with heat transfer. There are many books on heat transfer, guys. Believe me, it is one of the top and hottest topic that you may encounter out there, because this is not only an application from chemical engineers, but also for mechanical engineers, civil engineers, maybe even electrical engineers, and many other types of engineering. Heat transfer is, of course, one of the fundamentals of energy transport throughout the industry. We are going to be talking about cooling, we're going to be talking about heating, we're going to be talking about condensing, we're going to be talking about evaporation, we're going to be talking about boiling, and of course, the equipment that performs such operation. For this, I will strongly recommend you, once again, the almighty Sengel, which has a book on heat transfer. But also, guys, remember that these are general applications on heat transfer. If you want to focus a little bit more towards the equipment or design, definitely go for Process Heat Transfer by Kern. As you can imagine, this is a great book, but definitely you may encounter that this is a little bit dated. Another great book that I will recommend you is that of Linhart, a heat transfer textbook. Essentially, as the name implies, a textbook that covers heat transfer overall, some applications, and some problem solving. And really, guys, it will really depend on what are your needs. I couldn't select only one, because if you're looking for the general understanding of heat transfer overall, the phenomena, it will be that of Sengel. But if you want to focus your attention into actual engineering and industrial applications, that may be Kern for sure. But if you want to have a hybrid version, understanding the theoretical concepts, but also some applications, some solved problems, and so on, go for that of Linhart. Now, momentum transport or fluid mechanics, as you may encounter, is one of the top applications that you're going to encounter in the industry. Actually, this is not only for chemical engineers, but also mechanical, civil, and industrial engineers, and so on. I'm talking about pumping system, pipe flow, friction losses, Bernoulli theorems, maybe on the applications on compressors, multi-compressors, fluidized beds, valves, control valves, and much more. The applications are limitless. So, as you can imagine, this will also depend on what are your specific needs. Do you want to focus your attention towards theoretical understanding of momentum transport, the viscosity concepts, what's going on at the microscopic level, or maybe you want more on the applications themselves, maybe you just want to learn how to size a pump, how to operate it, how to select certain type of equipment, or maybe you want a general understanding on the topic. My best pick for fluid mechanics will be that book of MOT, Applied Fluid Mechanics, one of my favorite books of all times. I really can't stress the importance of this book in my understanding of fluid mechanics. I really love the way in which the author structured the book, but Not only that, guys, I also like the way they use terminology. Is of course not so fancy, straight to the point, but also the understanding of technical terms, and more importantly, guys, the solved problems are there. Of course, you get to understand them, but they go in hand with the proposed problems, which are of course challenging but kind of similar to those of the solved one, so the author pushes you a little bit more towards the understanding of the topic. Definitely a book worth having at home. And pretty similar to heat transfer, guys, fluid mechanics will have a lot of books. You may encounter very general books, but also a lot of books that focus their attention towards mechanical or chemical industry, maybe even into specific type of industries, let it be pharmaceutical industry, petrochemical industry, and so on. So definitely select based on your needs. One honorable mention is the book of Fluid Mechanics for Chemical Engineers by Wilkes. It's truly a jewel that you may encounter as well. As stated before, mod application is very focused towards industrial applications, pumping services with water, general applications that you may encounter in a lot of process industries. But if you already know that you're going to go into a chemical industry, definitely that of Wilkes is the best pick for you. One of my favorite topics in all chemical engineering is of course chemical reactor design, operation, simulation, and so on. And of course, you may encounter a lot of theoretical books that are going to be covering the kinetic part, but I'm going to stick to the actual chemical reactor design. Now, here we have three main goats, and in no particular order is number one, Introduction to Chemical Kinetics and Reactor Design, Charles Hill. Definitely a nice book. You will encounter a lot the theoretical concepts, all the theory that you need to understand in order to get started with chemical reactors, but also we talk about CSTRs, PFRs, batch reactors, how to work with them in series, parallel, conversion, and so on. Number two will be that of Octave Levenspiel, which is a traditional book to go through. The Chemical Reaction Engineering book is definitely one of the best books you will encounter in chemical engineering overall. They have a great approach towards learning, good problems, and of course a lot of industrial applications. And last but not least, guys, actually I have done already a review on that book, is the one of Scott Fowler's Elements of Chemical Reaction Engineering. This is by far one of my favorite books, not only because I love the topic, but also the way in which Scott Fowler approaches learning is one of my favorites. I don't know why, but I remember reading the book and it was like reading a novella or something that is not quite technical, and I was just reading and really enjoying all the technicalities on reactor engineering. Not only that, guys, it has a lot of solved problems, a lot of applications in the industry, a lot of technical facts, and more importantly, I really think it is one of the most well-rounded books when we're talking about chemical reactor design. Mass transfer or separation technologies or separation processes are kind of the same, but not quite. Let me get to it. So first thing first, either you are focused towards the theoretical concepts, the theory behind the unit operations, which will be a very deep dive into mass transfer, or maybe you just want to focus your attention into the actual equipment, let it be distillation, let it be extraction, lixiviation, membranes, or reverse osmosis. Whatever unit operation you're thinking about regarding separation process is of course going to be relevant for you when you're picking a book. So my best pick will be that of Jaime Benitez, Mass Transfer Operations, because it is one of the clearest, easygoing books that you will encounter out in engineering, specifically in separation processes. The book talks about, of course, the operations, not that much on the theoretical concepts or ideas that are going on behind the unit operation, although you have a small section on that, but if you want to learn straight into the topic, definitely this is your book. It talks about distillation, it talks about batch distillation, flash distillation, multi-component distillation, the McCabe-Thiele method, and of course, all other type of processes. Definitely one of the best picks for you. The book of Robert Trable is also a great book. I really love it. It is also very straightforward, although I think in some specific instances it may not have the best theoretical approach, and sometimes I really think that some specific sections should have been developed more than the way they do it, but generally speaking, this is also a great book. Separation Process Principles by Cedar is also one of my favorite ones. It's very straight to the point, and actually is this little book I have right here in the background. I really love it. It's very straight to the point, and as I said before, this is focused toward the separation process and separation technology, not that much into the understanding that's all behind the equipment. If you want to focus your attention into the theoretical concepts, if you're into Fick's law, if you're into diffusivity, if you really want to understand the film theories and all these concepts, I will strongly recommend you to go back to the book on Giancopoulos, which is Transfer Phenomena. Yes, of course, that's important, but the understanding of the actual principles that go behind the separation technologies. Now let's focus to process control, guys. And yes, I know that many of you just want to skip this part. You don't want to have anything to do with this topic. Although this topic is, of course, one of the misunderstood sections on chemical engineering, truth be told is that you're going to encounter this a lot throughout your process and chemical engineering life. Actually, I'm pretty sure that this is going to be something that you're going to encounter daily. Either because you want to work with sensors, you want to ensure that the thermocouple is working, you want to ensure that the valves are working properly, or maybe you just order a process specification change and don't know how the process is going to react. You are going to be working with process control. So, understanding the importance of this, let's stick to the most important books. Number one will be Process Dynamic and Control by Seaborg, and of course this is like the cathedral, the Bible of process control in chemical engineering. It is a very common book to encounter. It covers the fundamentals greatly and of course has a lot of applications in chemical processes, which in my opinion is the best part of any book. Yes, having the understanding, the theoretical understanding, but the applications must be those that you're going to encounter in real life. Process Control, a Practical Approach by Mike King is also one of the best picks I could encounter. This piece of art I encountered later on in my life when I was a young process engineer. I didn't know that much about process control, just the basic fundamentals that I got from university, and this book really helped me, not only because it has good fundamentals, but also it goes straight to the point. As the name implies, it is very practical approach towards the understanding of process control. And one honorable mention, guys, this book I haven't read. Actually, I am going to be making the recommendation on the recommendation of one of my best friends that works in chemical process control. And I'm talking about Wayne Beckett's book, Process Control, Modeling, Design and Simulation for Chemical Industry. And for this specific book, I cannot speak for myself, but my friend told me that this is one of the best books for process control. And not only that, guys, it also has some exercises on design and simulation for the specific applications of chemical engineering. And remember, guys, whenever you see a book with a yellow cover, you are for sure going to understand that this is a great book. So that's why I really trusted my friend. And finally, guys, the almighty books that talk about process design, process operation, process analysis, process optimization, and so are those that you're going to encounter by the millions. And I really understand why. The reality is that once that you go to the chemical industry, you're working with a process, you really want to know the solutions to certain type of processes or to certain type of technologies or even industries. And many books have focused their attention to this. My best pick will be that of Turton's book, Analysis, Synthesis and Design of Chemical Processes. Literally, this book has everything. You may encounter from basic flow diagrams, process flow diagrams, pipe and instrumentation diagrams, to thumb rules for certain applications on design of vessels or design of containers, or maybe understanding how a change in temperature in certain type of equipment is going to be affecting distillation or the final product quality. Not only that, guys, you will encounter that the book also covers finances and economics, maybe even project management. So just this is my go-to book when we're talking about these type of topics. And I want to make a honorable mention, the book of Chemical Engineering Design, Principles, Practice and Economics of Plant and Processes by Gavin Toller and Ray Sinot is definitely one book that you may want to check out. And why, you're asking? Well, it is really complementary to that of Turton's, so I will go definitely for that book first, and then whenever you see some topic is missing, it's most likely that you're going to encounter in this second book. And there you have it, guys. If you have at least 2/3 of the books that I just mentioned, it can be said that you have a very well-rounded library regarding chemical and process engineering. I'm pretty sure that if you have any doubt on heat transfer, you may check it out quickly. Or if you're talking about maybe process design, maybe we're talking about distillation processes, maybe we're talking about mass transfer equations or so, definitely you can encounter those in these books. And one important thing that I want to ask you guys, I'm pretty sure that you have knowledge of other books, other topics that you think that are quite relevant for this list. So please let me know in the comment section which other type of books would you recommend. Mass transfer, thermodynamics, transport phenomena, unit operations, reactor design, process control, process design, whatever the topic it may be, let us know in the comment section so we can explore them too. This is great not only for myself, but also for all the fellow young engineers that want to learn more about these topics via these books. I'm pretty sure that we really will appreciate that. And guys, as you have seen from the list, this is much more towards the academics being applied to the industry, but in the next video, I'm going to be planning a list on books that are much more hands-on into the process. Let it be handbooks, let it be books that help the process engineer, or whatever book I think is quite reasonable depending on the industry you're working in. On my behalf, that will be it, guys. I'll see you in the next